So the last thing that we have to conduct first before we start our design or construction of a particular highway or bridge structure is to conduct physical testing. So now the question is, why do we need to conduct physical testing? Why are we required to perform physical testing before starting a particular bridge structure or even on a rehabilitation of an existing structure? Why do we need to conduct physical testing? That's the question that will come into our mind. So we need to conduct physical testing to supply needed information concerning the adequacy of materials used in the construction of the bridge. So that's the main purpose of physical testing, to have a knowledge on the strength of the materials that are being used in the construction of a bridge project. So that's the main reason why we conduct physical testing. Although it's not limited to the construction of a new bridge, but it is we also conduct physical testing to the existing bridges to know to have a knowledge on the present performance or adequacy of the materials that are used as components of that particular existing bridge. So overall, we conduct physical testing to have a knowledge, to have an information about the material that are used in the construction of a particular bridge or highway project. So there are actually different methods of physical testing. And the first one that we will study on this discussion is the coring coring or core testing. Coring is performed when components of the bridge are to stay in place to ensure the adequacy of the material to remain. Structural cores should be taken at key points in certain concrete elements such as piers, in pier caps. So the core must be located or collected from the pier caps themselves in the case of piers, and in the abutment stems for the case of abutments. And then after collecting those structural cores, compression tests are then performed at the testing laboratory to indicate the strength of the samples taken. For timber structures, cores are taken to determine the moisture content and the extent of decay within the timber element. So the first method of physical testing that we will study on this discussion is the coring. So this is actually the actual coring procedure. So as you can see here, this is actually the diamond core drilling procedure. As you can see on the GIF, uh, we conduct coring, or we bore holes, or we drill hole on the particular component of a bridge or any structure that we want to subject to core testing. So as you can see there, we usually use a special equipment that is used to core a hole or to drill a hole onto the concrete part of a structure. So again, we conduct that physical testing, the coring, to ensure the adequacy of the material to remain here. So usually we conduct coring for those bridge components that are needed to stay in place, because obviously we cannot subject uh, to compressive tests those actual bridge components that are already or that are already erected on site. Obviously we cannot subject them to compression tests, so we just have to take some of its component, or some of its part, and then uh, take that core sample to the testing laboratory and subject it to compression tests for us to know the present uh, performance or present strength of that particular uh, component of the bridge structure. So that is usually the whole process of coring. We core a hole or we drill a hole onto the particular bridge component, and then that core sample will be taken to a laboratory, a testing laboratory, and will be subjected to compression tests so that the performance or the current strength of the whole component will be known. So with that, we can have an idea on the adequacy of the whole component that remained on site. So technically, we are assuming that the strength that we will get from the core sample will represent the strength of the whole component of the bridge structure. Although that's for the case only of concrete bridge components. So for the case of timber structures, we usually conduct coring for the purpose of determining the moisture content of the timber structure as well as the extent of decay within the timber element. So again, just like what I've said before, we don't usually core holes on any part of a bridge component. We usually core holes or core yeah we usually core holes on the bridge component on a particular key location. Like for example, on the case of piers, we just don't bore a hole or core a hole on the pier itself. We usually bore a hole on the pier cups. And for the case of abutments, we usually core a hole. We usually get a core sample from the abutment stems. So we don't just core a hole randomly. We usually core a hole. We usually get a core sample on key locations on the particular bridge component.